you all. On behalf of Docomomo, Hawaii, I'd like to welcome you to our 2021 annual tour day event. As you know, this event will be recorded. We are actually broadcasting live from the former top of Ilikai, now the new Pesca Waikiki Beach restaurant, which opened just 7 weeks ago. And they're actually just prepping for happy hour, so there's a little bit of noise going on right now. The general manager, Alan Hirano, has been so gracious and supportive of this event. And it's quite a treat to be here, especially since the Ilikai is one of our buildings we will be highlighting today. I see so many familiar names with us today and a lot of new names too. So thank you all very much for joining us. This has to be by far our most best attended event yet. And I am quite humbly honored to be a part of it. For those of you who don't know me, I am Alyssa Carson, the current president of Docomomo Hawaii chapter and an associate at Fung Associates. Docomomo is an international and national organization which stands for the documentation, conservation of buildings, sites, and neighborhoods of the modern movement. Our Hawaii chapter is an all-volunteer and registered 501c3 nonprofit organization, and we aim to promote public awareness and education, focusing on Hawaii's mid-century modern era, which is the time between the late 1940s and about until the early 1970s. Today marks quite a special time. It's our 10th year participating in the Docomomo US National Tour Day. Tour Day is an event coordinated by Docomomo National, celebrating architecture and design across the US. Each year, Docomomo chapters, partners, and other organizations around the nation host an event on the same day or throughout the month of October using a selected theme. And this year's theme is travel and leisure. With the theme of travel and leisure, our Hawaii chapter naturally gravitated towards looking around areas in Waikiki. We couldn't help but find Alfred Yee's name connected to many of the buildings in the area. That's why we are honoring this year's tour day to him. This tour allowed Docomomo Hawaii to use many of the boxes of project archives that were donated by Alfred Yee's office, as well as provide the opportunity to partner with the University of Hawaii's School of Architecture and School of Engineering, who recently actually completed an incredible exhibit called Alfred Yee Modern Connections, which is located in the Haigo and Irene Shen Architecture Gallery. Before I move on, I want to recognize all of our amazing sponsors for this event. I know many of the principals of these firms are here with us today, so thank you to you all, and happy Bosses Day, by the way. Without your support, this event would not be such a success. So a huge mahalo to Fung Associates, Nagamine Okawa Engineers, GPRM Prestressed, AHL, Akamai Structural, Allison Ide Structural Engineers, Downstream, Kai Hawaii, Martin Chop Carden, Tadpole Studios, Tileco, Joe Uno and Associates, and especially Hone Blue for generously printing and donating all the booklets we put together for this event. We put booklets together as a supplement to this tour. One is a hard copy tour booklet, which we sent as an electronic file yesterday with the Zoom link info. And the other book provides more information about the individual buildings that we'll be talking about today. For those of you who have already purchased the booklets, thank you for your purchase. We have placed the booklets in the mail, and hopefully they have arrived in your mailboxes. And if not, they should be arriving soon. We have just a few booklets left to sell. So if anybody wants to purchase one, you may purchase them on our Eventbrite page, and the link will be posted in our chat. Just a few more thank yous. I'd like to thank all of our guest speakers today, who you'll be introduced to you shortly. And I also want to, I also understand many of the Yee family members are here with us today as well. Knowing you all are here with us makes this event so much more special to us. So a sincere thank you to you all. At this time, I'd like to pass it over to Louis Fung, who is actually here with us today. He is the principal of Fung Associates and our title sponsor of today's event. So I'd like to give him a moment to say a few words. Just one moment.
Oh,
Let's see. I don't know how to change it.
okay. Hi, everyone. Good afternoon, everyone. I understand some of the Yee family members are here. So first of all, I want to say hi to all the Yee family. And some 25 years ago, I met Alfred, not professionally, but at my cafe downstairs of his office at the Ala Moana building. And to me, at that time, Alfred was a great engineer with a fabulous family. And perhaps to Alfred at that time, I was just an architect who knows coffee and sandwiches. I think that's it. And one time I remember when I asked Alfred, why do you like our sandwiches and coffee? And he said, well, because they are not prefab. So I thought, well, a prefab remark coming from a prefab master, I take it as a great compliment. And several years ago, when National Trust called upon us to try to save the natatorium from demolition, we formed a team, and I had the great pleasure working with Alfred, as well as another pioneer, Dr. Hans Kroc. He is also a pioneer in oceanography. And so we're very happy that the natatorium still stands today. And today we are very privileged and proud to be able to sponsor just a little bit for Docomomo and to make things happen. And to that, I really like to thank everyone at Docomomo putting this enormous event together. And I also want to say aloha again to the Yee family. Aloha, everyone. Thank you.
Well, thank you, Louis. Okay, so we'll just move on now, and just a few housekeeping notes before we move on. This is an accredited AIA course, which we are offering 1.5 learning units. For those of you who do need these credits, please email Docomomo National directly with the information noted on the screen. We will also post this information in the chat. We'll also be taking attendance of everyone here online, and we'll send the list to National for their verification. Credits will only be given to those in attendance today. If you want to be added to our email list or have any questions, want to learn more about us or become a member, please check us out on our website or send an email. Our contact info will also be placed in the chat. And lastly, with the chat function, please feel free to type in any questions you may have during the presentation. We will collect the questions at the end, and we'll try to have them answered at the end of the presentation with the remaining time that we will have left. So moving on to today's event format, in addition to our slideshow and guest speakers, We will have Keith Short and Kelsey Liu on the ground to provide real-time footage of the buildings that we are featuring, so you can see them live. Kind of our way of making it like a physical walking tour, except in the comfort of your own home. And actually it's a little bit sprinkling outside, so maybe it's better to be indoors anyway. So without further ado, I will pass it over to Bundant Kunistakan and Kelsey Liu, both board members of Docomomo, Hawaii, and our chairs for this event. Thank you, and I hope you enjoy the presentation.
Okay, hi everyone. I'm Bundit Kunistakan. I'm an assistant professor at the University of Hawaii School of Architecture, and I'm honored to be here to share some wisdom of Alfred Yee's work in Waikiki, Honolulu area. So I'm also a curator at Heiko and Irene Chen Gallery, who made this possible with all the funding and things from them, and the time and the space, and from everyone at the School of Architecture that helped me, including the fellow students who's been volunteering for this, and good friends as well. So without further ado, I just want to introduce Alfred Yee's own daughter, who has been our friend for quite some time, Suling Yee. She's very talented person. She has both degree in structural engineer and architecture, all in one from University of Pennsylvania. And she's kindly shared with us about what she thinks about her dad and his professions. Thank you.
And associates. Thank you, Bundit. Thank you, University of Hawaii Architecture and Engineering Departments. And thank you, Fung and Associates, for putting together this historic event. Thank you to all of you for your presence, your passion for architecture in Hawaii, and your interest in my dad, Alfred Alphonse Yee, and his associates in the pioneering work they did in the building of modern Honolulu. My name is Suling Yee, and I am the 6th child of Alfred Yee out of 8. My dad was prolific in many ways. Like many others, I too was inspired by my dad to study architecture and engineering. Growing up, I would hear endless stories about exciting projects from around the world and endless talk of new solutions to old problems. My dad's passion to find and perfect again and again the most simple, the most elegant, the most ingenious, and economical solution to any design problem is what launched his career and kept him growing strong throughout his entire life. It was impossible for me to resist the seduction of his beautiful mind and great ideas. From the underwater bridge supporting the USS Arizona Memorial to the glorious exposed structure of the Kahala Resort and the ubiquitous splice sleeve, my dad's bold designs and clever innovations changed the way we think about structures and shaped the way we build today. He was passionate about engineering, yes, but he was also passionate about life. He loved music, and he could play the piano, the guitar, the cello, and the accordion. When he was 10 years old, he won a talent competition with his accordion and was invited to accompany Shirley Temple while she tap danced on stage. He taught us 8 children to play guitar and sing his favorite Hawaiian songs. We would have epic jam sessions lasting late into the night. And on occasion, we still get together and sing. Back in the day, my dad was a big, handsome guy. Everyone called him Big Al, and he was the life of the party. The party didn't start till Big Al got there. He'd remember names, dates, stories of all the people he met and would go around the room making fantastic impromptu speeches about everyone there. He made people feel special because he genuinely cared for others, and people were drawn to him because his enthusiasm was infectious. My dad was full of aloha, and he passed on to those around him his unique perspective on life, which was based on compassion, humor, love, and respect for others. He acted with the highest integrity, and as a result, would prefer to be on the short end of any deal. As long as he knew he was doing the right thing by himself and giving more than he was getting back, he was happy. As much as this was not the most logical business strategy, it always yielded great returns in the form of goodwill and aloha. I also have to give it up to my mom, the beautiful and glamorous Elizabeth Yee, who gave my dad the steady love and support he needed so he could give so much to others. My dad would always say that he's just a barefoot Hawaiian boy. And while he had so many great accomplishments and reached the highest level in his field, he remained grounded and very proud of where he came from. So mahalo again for joining us today and revisiting the passion and ideas of a barefoot Hawaiian boy. I hope you enjoy the tour. Thank you.
Oh, thank you, Suling, for all your kind words. I hope you are listening. I know you have something going on now in the Bay Area, but it's so nice to see you and to have you as a part of this event. For me, I think when you look at Hawaii, we have to ship in a lot of materials from outer island and other places in the world. And precast concrete is one of those material that is nice to be able to use it and cast it, on our island. That's the way that we can save a lot of energy and cost and headache to be able to bring it in efficiently. This is just a building material map that we start to do some research in our structure class to be able to show you. Next slide, please. When I talk about precast, the way I think about it, I always compare precast concrete as making bread, because I enjoy eating. And when you make bread, when you try to do it, imagine that you have to go grab ingredients from each household and go to the grocery store and buy flour, salt, and eggs and all those things. It's a lot of work. But through the if you have one big oven and a house that can make the bread, so people can, come and get the bread or share the bread without having individually, go out and buy materials or ingredients at the supermarket. Precasting is the same thing. That's something that always stuck with me about it. And some of the bread, people ask me like, oh, can it be healthier precast? I said, yes. Some of the bread you do whole grain, you do some of it, you put some raisin in it, and some of it there's spice and other things. That's something that we can consider incorporating this idea into the local precast concrete. And not only that, some of the crush up concrete after the building get demolished, people ask me, what is it like to get crush up concrete and reuse again? I said, why don't you look at croutons? Sometimes broken up things can jazz up your flavor of your salad in many different texture and make it more flavorful when you consume your food. So that's, my analogy about this talk. I hope you enjoy it. So next thing, I'd like to introduce the first speaker that's gonna talk about this building called 1717 Ala Wai, Tim Goshi. Tim is a good friend and we just recently got to know each other young and upcoming structural engineer that's very talented and very easy to work with. I'm just gonna give the stage to Tim. So, and this is some of the, yeah.
Hawaii. Hi, my name is Tim Goshi. I'm a local structural engineer at Kai, Hawaii. It's quite an honor and privilege to be participating in such an important event like today, to examine someone we all revere as a local legend in the AE community here. Although I never had the opportunity to meet Alfred Yee, my connection comes in the form of his son, Trevor, who I would go tailgating with at UH football games, since we both share an immense affinity for Warrior football. Similarly, I have been able to work with one of his proteges, Mr. Benzo, who has worked as a consultant to our firm in the last several years. You know, feeling compelled to find out more about Mr. Yee, I also reached out to his wife, Mrs. Elizabeth Yee, and the message that they all portrayed was consistent, that Mr. Yee was, you know, he appreciated the simplicity of things, particularly the concept of precasting and pre-stressing concrete in order to achieve greater economies with larger spans, thinner floors in the architectural and structural design. Always want to make others feel important, including clients near and far. Mr. Yee's legacy is captured not only in the buildings he helped design and build, but in the relationships that still exist today among his colleagues, friends, and family. So I'm going to share a little bit about 1717 Ala Wai, a building that he completed in 1969. It was a $12 million project that featured 31 stories and 283 units. Each of those units were in different sizes and square footages. So they range from $29,000 and $86,000 respectively. And they sold out in 3 days. Back then, the marketing included such things as carpeting, drapery, electrical appliances even. But in order to build this building, which we'll dive into in a second, they had to demolish an existing 3-story building on site. And it's interesting to look at some of the photos that are archived in the local newspapers back then, because that was still during a time when people came out to watch building demolitions, which is something I think people nowadays would enjoy to see. Built by Hawaiian Dredging back in 1969, the developer was Dillingham Development Co. They were quite prominent during that era. And kind of a funny story, Mrs. Yee once said that Al would complain about developers not calling him back. And she explained that the 15-minute sketches that he would do, usually on a napkin or on a small piece of paper, was so detailed and so developed that these developers would take these sketches that were just drawn on site and not call them back. And they would give those sketches to their own engineers. After this was realized, after some time, Elizabeth forbade him to use any more napkins, and so that was kind of a funny little anecdote that his brilliance was captured on such a small media, and it led to probably some developers just using that instead, right? So instead, he was confined to using his green pen and sketch pad from that point going forward. The architect of record back then was Bauer, Maury, and Lam, and the building itself included a 14,000 square foot rec deck with swimming pool, shower, sauna, baths, you name it. Back then, it was marketed as a more elegant building. It is located 90 feet from the Ala Wai Canal, which is, as you know, kind of in the heart of Waikiki and really close to local businesses and the beach as well. The first 2 levels of the building are primarily for parking. They also include a rec deck level, which faces the Ala Wai. It's an interesting geometry in that it's almost an L-shaped building. The 2 wings are positioned roughly at 78 degrees, which kind of offers just dramatically differing views for the outward facing lanais, and more of a communal feel for the inward facing corridor that is at that slightly acute angle. The foundation system utilized driven precast concrete piles with pile caps that were connected with tie beams. So very, very typical of what we'd expect in Waikiki given the known soil strata in the area. Back then, the lateral design isn't what it is today, but that being said, it was still very similar to what we would do today in that it utilized a lot of reinforced concrete shear walls, a lot of them being aligned in demising applications, as well as the elevated core on one of the wings. But really the meat and potatoes of this building in the context of Mr. Yee was the precast elements. So coming up off the ground, we had the reinforced concrete columns and walls that were supporting in place concrete beams and girders, which then supported much of the precast elements, which included the precast joists, which had different varying depths. Also the precast stair treads, which we still do today. The typical floor framing consisted of 3.5-inch lightweight concrete precast panel planks with a 2.5-inch lightweight concrete topping, which spanned the typical 24-foot bays of each tower. But probably the most iconic portion of this building, which as any person that visits this building would see, are the precast lanais that are outward facing, as I mentioned previously. These are also the 3.5-inch thick precast members, and they feature this slightly radial elliptical curvature, which really gives the building a very distinguishable look. One of his philosophies after interviewing Trevor, Elizabeth, and Ben really came through on this building even, right? Is that less is more, was to make things very simple, but very elegant at the same time. To take that one step further into the structural engineering realm, one of his other philosophies was to ensure that the precast connections behave monolithically. So that meant adding more reinforcing bars so that if there was ever bearing lost or compromised, that the precast member wouldn't just fall down, wouldn't just fall off of its bearing connection. So that having that redundancy and that sort of forward thinking, I feel really captures what Mr. Yee was about in terms of design and application of his technology and the concepts that he developed, which, as we all can see through this presentation, could be captured in 3 words, in my opinion: simple, detailed, and timeless.
All right. Thank you, Tim. I hope you're still listening. So yeah, we also have Kelsey out on the ground. Kelsey, are you there, Kelsey?
Yep, I'm here,
okay.
Bandit.
Yeah, would you mind showing some of the 1717 Ala Wai building on the ground? Yeah, sure. That's awesome.
So as you guys can see, just to get a feel for the neighborhood, here is the Ala Wai Canal with the convention center across the street. As we pan over, you start to see all 31 floors of 1717, with the penthouses at the top and the nice slender precast balconies.
That's good. Yeah, this is very good. Thank you. And when you look at the precast balcony, those are the elements that I think it's very helpful to cast everything in kapolei and truck it in. Imagine when you make bread and you really have to clean up every time. How many times that you have to clean up your baking pan. But if you do it one time in kapolei, you just do it one time. So you can keep using, the same pouring platform and just keep reusing it and using it. You save a lot of plywood to creating a formwork when you do the side cast. It's going to be very difficult, and this is way more efficient. And not only that, when you do precast, you can control the slope of the drainage that can drain the water outside your building right away. So that's something that we see a lot in his building, that there's almost no spalling in all his building that he designed cleverly and wisely. That's something that I see in this building. Okay. Yeah, look at the pictures. Yeah, this is it. Yeah, that's how. Yeah, that's the precast, and how every individual balcony get cast in couple and truck it in. This is very good. Thank you, Kelsey. Okay, why don't we move on to the next one? Okay, the Waipuna Apartment. Myles, are you there? Myles also worked with Al for quite some time and I first had conversation with Myles. I think a couple months ago. He become one of the Myles associate that gets sent to Asia to set up a precast factory or plant in Southeast Asia, and very knowledgeable person that and very friendly at the same time. So, and he knows so much about all these precast from the ground up, set up the plan, delivering it, and come up with a way to put it together. And he's going to talk about the Waipuna Apartments. That's something that I'm looking forward to hear more about it. Here's to you, Myles. Please share with us.
Thank you, Docomomo. I watched this building go up, and I'm completely dating myself. In fact, one of my sons was Tim Goshi's classmate in grad school, so there's a generation there. But my first job out of college was as an engineer with the Federal Aviation Agency, and they were located right in Waikiki on Kalakaua and Ala Wai. So we'd walk over for lunch maybe once a week to Ina Road. There was a diner there, and it was right across the job site. So from this diner, I kind of got a time-lapsed view of the construction. I looked over some of the sales information that Bundit's group sent, and the sales publications touted one major selling point for this property, and that is that there was an acre of the site set aside for the construction of a large lake fed by clear artesian ponds, and hence the name Waipuna, spring water. And it was also noted that these ponds were once a sanctuary for native island waterfowl and migratory birds. And I'm thinking, whoops, in today's terminology, that was a wetland. The design team was comprised of Bauer, Mori, and Lam, same as the 1717 building. Structural engineer, of course, Alfred Yee and Associates, and landscape architect George Walters, because the landscaping plays such a large part in this property's development. General contractor, Hawaiian Dredging and Construction, and the developer was a joint venture between MetLife, Metropolitan Life, out of New York, and Dillingham Land. The Waipuna was completed in 1972, and by the late 70s, new high-rises in this Hobron, Ina Road area made it probably the most densely populated neighborhood in Honolulu. The Waipuna is a 38-story reinforced concrete building. There are 406 units. Structural system, as Tim Goshi mentioned on his building, load-bearing shear walls. And these are typical pretty much to just about every high-rise in Honolulu. The floor system is comprised of a 3-inch thick precast, pre-stressed concrete plank, solid planks, and these planks were typically 9 feet wide. And the reason for 9 feet was that is the maximum width that you can truck a piece of anything over the roadways from precast plant to a job site. And on top of the planks was poured 3 inches of cast-in-place concrete. And that made the total slab thickness just about in the range of 6 inches. So this marriage between precast and cast in place concrete was Al Yee's go-to system. And he called it a precast composite. Again, a composite between what's cast somewhere else and cast on site. So the precast composite system had numerous advantages, and I'm sure these will come up again and again, but primary was the speed of construction, because the precast components could be fabricated well ahead of time and stored off-site until they were needed. And then when they were installed, the planks actually acted as stay-in-place forms. So that eliminated the need, as Bundit mentioned, to construct wood forms for a cast-in-place slab and then have to strip them later on. The adjacent planks were connected to one another, either with welded or bend-down ties. And if you look at that photo again of Bundit's loaf of bread, you'll see there's a stack of precast planks with what we used to call porcupines, and those were bent down to stitch the adjacent planks to one another. The there it is. See all that rebar sticking out of the edges. Those are the bend down ties, and I think this is the HC&D plant which I had worked on. And finally, a backer rod, a sponge backer rod, was jammed between the joints, between the planks, to keep the water and the moisture from coming through from the poured in place topping. Another advantage of precast is better quality control when you have production under plant conditions. There were also material savings. With the higher strength steel and higher strength concrete, you could go to longer spans and thinner sections, thinner slabs. And of course, thinner sections mean less building weight, less foundation loads, foundation savings. Also, a lighter building weight relates to lower earthquake forces. So lots of advantages there. And finally, the concrete poured on top of the planks had several benefits. The 3 inches of topping, in Waipuna's case, accommodated electrical conduits and other utilities to be run in the topping. And the cast in place topping also accommodated negative reinforcing bars, which result in a more efficient continuous span designs. The topping also allowed for other precast elements, such as the lanai slabs at 1717, and I think at Waipuna, to be merged into the system without having to resort to detailed welded or epoxied connections. And finally, as the ultimate practical engineer, Al Yee knew that a poured topping would cover up any irregularities in the precast components, such as differential cambers or dimensional differences. You know, today's walk is titled Al Yee, a Modern Precast Pioneer. And if I can digress just a little, in the mid-1950s, and I think this is in the reading, that Al and his partner, Katie Park, also another structural engineer, started a company called Concrete Engineering. And this was a joint venture with HC&D. HC&D is still making ready-mix concrete today out in Sand Island. And this is one of the very earliest precast plants in the United States. So think about where that technology was at this time. So Al was an entrepreneur, not just a great engineer, an entrepreneur, and truly a pioneer in this industry. And this is actually how I first met Al Yee. After the FAA, my second job was as a plant engineer at Concrete Engineering. Well, by the time I got there, Al was long gone. He had divested his interest in the company, but he would still call us in on occasion to come over and talk about one of his latest projects and some novel idea to precast some of the components. And we'd look at it and try to think how it might get built. You know, we looked at precast concrete sheet piles and very tall wall panels using T-sections, and mentioned previously some very large projects where precast components were site cast for housing developments. Al always had a great enthusiasm, and I saw him as a super salesman, and I mean this in the most complimentary way. You know, I remember at one of these meetings, Al told me, he said, "Hey, Myles, look at this." And he handed me a hardcover book that was titled Everything I Know About Engineering. So I opened it, and they're all blank pages. And he kind of laughed and he says, "You can never know everything." And that was a lesson in humility. You know, I also was a sales engineer for Eats Indie selling precast products, and I got to know almost all of the structural engineers in town. And I had to say, these were some of the grumpiest guys you'd ever want to know. But Al had the most unusual quality. He's the only one out there who had charisma. Well, getting back to Waipuna, as previously mentioned, the lake was a central showpiece of this property. And in one of the sales articles, there was a quote from the New York developer. And let me read this. The quote says, "We're going to fill it," talking about the lake, "with thousands of expensive fish, mostly colorful carp from Japan. And they," talking about the fish, "will be a standing or swimming temptation. How to keep the residents from surreptitiously netting a free dinner? Well, for one thing, we're going to have a house rule that says no fishing." So clearly, mainland developer was out of touch with being concerned that the Hawaii buyers were a bunch of natives eager to eat anything. The construction cost was $22,1971, and selling prices started at $34,000 for a one bedroom, up to $155,000 for the penthouse. It was a 75-year leasehold, though, with the first 40 years fixed and an 8.75% interest rate. And one last little known fact, Senator Danny Noy lived in this building. Thank you.
Oh, hi, Kelsey. Are you still by Waipuna area? And Keith. Yeah. Can you share with us what it looks like?
So that's over there.
All right. Yeah.
So we're over by the old 7-Eleven and the Irish Rose.
Okay. This is great. You know, as you can see, this is very resemble 1717 Ala Wai, but you start to see some curve and some different facets of the building to push the limit a little bit. And this also does remind me of another building that if you were to do another walking tour called Marco Polo, that I'd like to share later on. That's for the second episode of walking tour, just FYI. Other than that, should we move on to another building? Yeah, okay. Thank you so much, Keith. Okay, the next one. All right, is where we are at now is the Ilikai Hotel. The speaker for this one is Dr. Ian Robertson. He's a professor at the School of Engineering, very wonderful person and very supportive, you know, and the way he explained things is very easy to understand. And he's also very approachable. He has some personal connection with this project in particular, because when he started moving here from the mainland, this is the first place that he stayed. And let's see what he has to share in this video. All right, thank you.
Thanks very much, Bandit.
Yeah.
Yes, indeed. So I have the personal history that when my wife and I and our two young children came from Houston, Texas, to beautiful Hawaii to take a job at the university. We stayed in a hotel in Waikiki for the first night, but then we found a rental unit on the, I don't know, it was the 21st, 22nd floor. If you look at the left-hand wing, so the Ilikai Hotel is a Y-shaped, so that every wing has almost a perfect view of the ocean. The backside obviously has a view of the mountains. But on the left-hand wing, shown on this image on the left, we had one of those rooms. And the view over the Ala Wai yacht harbor and towards the sunset was just magic. So it was a wonderful introduction to Hawaii, to live in this building. And had no idea, of course, that it was Al Yee design, didn't know Al Yee. But I've been at the university now for 29 years. I serve as the Arthur Chu Distinguished Professor. I'd like to recognize another exceptional engineer in Hawaii, Arthur Chu. But I met Al Yee because he became an adjunct faculty member in the Civil and Environmental Engineering Department and gave a number of seminars to our faculty, students, and whoever was interested. And I was always fascinated by the stories he told of innovation, of long span bridges, of floating concrete barges, of massive semicircular hangars on Guam. The man was incredible in how he thought about complex problems and made them simple. And who in their right mind in the 1960s would have the guts to tackle the structural engineering of a building this large? It ended up being the largest pre-stressed apartment building in the world, at least for a while. It became famous, of course, because it was in the credits for the, now I've forgotten the show, what's it called? Anyway, Bandit will remember and he'll remind us. Yeah, it's a fascinating building. It incorporates a lot of the attributes that Myles was talking about of the precasting with you see it in the right-hand figure, the precast elements, and then with a topping to level out the floors. And as Myles mentioned, the beauty of precasting is both the precision with which the reinforcing can be placed so that we ensure the right amount of concrete cover. Also, the quality of the concrete can be controlled in the factory much better than it can on site, which is one of the reasons that Al Yee's buildings have a lot less spalling issues than buildings of a similar age. In addition, as Myles was mentioning, you can see on the right-hand figure, all of the electrical conduits could be set into that topping slab so as to simplify the construction. These are ideas that had not been used a lot in the past. Al Yee was one who certainly brought them to Hawaii. The other one he brought was pre-stressed concrete. Actually, I'll save the discussion of pre-stressed concrete to the expansion of the Ala Moana shopping center parking area. I know Bandit, he told me when he asked me to do these talks, he said, we have 5 minutes per building. I said, you can't talk about Al Yee's work in 5 minutes. I mean, it's ridiculous. So, but I'll save the pre-stressed concrete for that building. Yeah, so just the fact that this building had as many units as it had was obviously one of the tallest buildings in Hawaii at the time, but also had shopping centers down at the lower levels. A lot of it was cast in place. You see figures here of the cast in place columns and walls, and even some of the slabs were cast in place. But if he could use precast material instead of cast in place, he would, because the difficulty of making sure that all of this reinforcing is in exactly the right place in the field, and the expense of putting up the formwork. You see the gentleman on the right-hand side sitting on top of a piece of formwork. That formwork could probably be used 3, 4, maybe 5 times before it started to deteriorate. It's just plywood. Now they have more sophisticated plywood that can take many cycles. But if you precast in the couple A, you can use steel forms, custom made, and you can reuse them hundreds of times. You also don't have to support them. These guys are sitting on top of this plywood, but it's supported by joists, which are supported by scaffolding. And all of that scaffolding goes away if you use precast elements. The precast elements become the formwork. They support themselves. They support the concrete topping that's added on top. So an absolute genius as a structural engineer, Al Yee. And it's a shame that our students in the future won't be able to hear him speaking. And I don't know that we recorded. In fact, I know I didn't record any of the presentations he made in the past, but I wish now that I had, because that legacy is something we should save. So thanks very much, Bandit, for putting on this Docomo tour. I'm very glad to be a part of it. I see Kelsey has a live shot for you. You're muted.
oh,
You're
sorry.
muted, Bandit. Bandit.
Yeah, sorry. Yeah, I'm muted. Kelsey is down on the ground showing the Ilikai, and we are up at the top of the Ilikai, just having some water at the moment. Yeah, so that's where. Yeah, this is a good restaurant. Come join us. Okay, awesome. Yeah, this is great. And Richard is in the background. He's a city planner that's overlooking the city. So this is fantastic. So should we move on to the next building, Ian?
Keith also has a live shot of the Ilikai.
What was that, Kelsey?
Keith also has a live shot of the other side of the Ilikai, so
All
everyone
right.
can see.
Okay. So this, yeah. So next one, we can take a break now and we can come back to do, because after the Ilikai, it will be other building in that area that Ian Robertson would like to talk about, which is the Ala Moana parking and also the Ala Moana Hotel and the parking structure. And the Sunset Tower will be afterward. Yeah, and 1350 Ala Moana. So that's the list of building that we're gonna go through. Yeah, why don't we take a quick break? And then because it's been quite some time and we come back around 3 p.m. Please stay tuned. Would that be okay, Ian?
Yeah, it's fine. Except I'm not going to talk about the Equus. I think somebody else was talking about the Equus. You've got that one up next.
I know.
And then, so I don't know if you're changing the order, but that's fine. I'm ready anytime.
Yeah. All right. Thank you so much, Ian, for becoming a part of this. Very, very appreciative of that. Okay. Yeah. All right, we're back. It's 3 p.m. now. Yeah, I'd like to continue with our discussion with other building that I found it's very interesting for me to learn about it.
Hello.
Oh. Yeah, it's actually a simple things which involved with piling. Ian, are you still there, Ian?
Yes, absolutely.
Yeah. So, Graham, it's actually Ala Moana Hotel parking garage that what Ian Robertson is going to be talking about. Yeah. Yeah, back a little bit more. The parking garage.
Yeah, this one.
Yeah, so this one. Yeah.
Okay.
Yeah.
Shall I
Yeah,
go?
go ahead, Ian. Yeah.
Bandit?
Please do.
Okay, sure.
Yeah.
So, so not only was Al Yee fascinated with precasting concrete, he saw the benefits. By the way, the unions, the labor unions, did not see the benefits of precasting because it reduced the amount of work on site. Tying the rebar, building the formwork, carpentry on site was reduced because they were doing it in the factory. Of course, it required workers in the factory, but it was more efficient, required fewer people. So he met some opposition from the labor of the day. But now it's become a standard to precast many, many concrete sections. But one thing Al learned was that just precasting didn't solve all of the problems. So if you think about a pile being driven into the ground, and we used precast piles for a long time, the Navy has used them in the Pearl Harbor for decades, since the war and before. They would use large square piles with reinforcing inside, reinforcing bars. But when you pound something like a nail or something on the top with a large weight, so to drive a pile into the mud of Pearl Harbor, you would pound on it with a massive steel hammer. That induces a compression wave, which travels down the length of the pile. And when it reaches the bottom of the pile, if there's something soft there, there's nothing for it to react against. And so it comes back up the pile as a tension wave. And concrete is never good at carrying tension. And so nobody knew this, but these piles were cracking in tension because of that returning tension wave, until people started excavating for whatever reason to build a new building with a deeper basement, whatever. They found that piles were actually cracked, which allows moisture and salt and everything into the steel, causes corrosion, and you don't really have the foundation you thought you had. So Al was one of the first to realize that pre-stressing a pile could solve this problem. Because by pre-stressing the pile, and I'm going to show you a very crude mimic of a reinforced concrete. So I know this is wood, but imagine it's reinforced concrete and it has a steel rod running down the middle. In regular reinforced concrete, that steel rod is passive. It's just sitting there. Now my camera is not liking to focus on this, but so you might not see, but if I bend this specimen, joints open up. Oh, it's very hard to see. I should have tried this beforehand. Hey, Bandit. But joints open up, which basically the concrete cracks. So if I tighten this piece of rebar that I have in the middle, so now I've got little wing nuts on the end. I tighten it as hard as I can, and I try to bend this specimen. Now it won't bend at all, right? It's extremely stiff because I have pre-compressed the concrete, or in this case, the wood. I've pre-compressed it so that it's all in compression. Now, when I drive it into the ground and I pound on the top, that compression wave goes down to the bottom. It comes back as a tension wave, but as long as that tension is less than the pre-compression that I've already put into it, then it never goes into tension. It just reduces the pre-compression. And so the piles don't crack. And from that day forward, everybody has pre-stressed their piles. There are no more reinforced concrete piles. They're all pre-stressed. And that's what you're looking at here is the Ala Moana Parking Garage. So normally a pile is driven down into the ground until it hits something hard, like a coral layer, or at least develops enough friction that it can support the load. And then we cut the top of the pile off and we build a pile cap, concrete footing on top of the pile. And then we build a column on top of that footing that goes up to support the rest of the building. And Al Yee said, what a waste. Why do we build a pile cap on top of a pile? Let's just start with a longer pile and leave a big chunk of that pile sticking out of the ground. And then we'll chop it off just where we need it for our first floor, our first elevated structural floor, or the second floor of the parking garage. So that's why when you drive through the Ala Wai, the Ala Moana Parking Garage, you'll see all these piles. These are the piles supporting the building, but also acting as the columns on the first floor. Genius idea. Saved a lot of money in the foundation system. In addition, he was one of the ones who turned to octagonal piles, because a square pile, A, looks ugly, but normally they're under the ground, so who cares? But an octagonal pile is much more attractive and less likely to scratch your car when you drive by those sharp corners on the square pile. So this is what you see in Ala Moana Shopping Center. On top of that, he placed precast beams. So the beams that are spanning between these columns are precast and pre-stressed, so that he can make longer spans with a shallower member. And then over the top of that is the casting. I believe these were cast in place slabs instead of the panels. Now, another interesting story with this parking garage, there was a truck that drove into the parking garage and damaged one of these beams. It was too tall to fit underneath. And so back in the early 90s or late 80s, one of these beams was damaged. And the decision was to repair it in place by using carbon fiber fabric, a fiber reinforced, similar to your glass fiber surfboard, but using carbon fiber, was glued on the bottom of the beam. And then that portion of the parking garage was going to be demolished to develop the newer parking, multi-story parking structure that they have there now. This is on the Ever Malka corner of the parking area. And we knew about this repaired beam, and so we asked the demolition crew if they could go in and cut that off for us at both ends, so we could bring that beam and one other beam back to the structures lab at the University of Hawaii and test them to see the difference between the original beam as designed by Alfred Yee and the beam with this carbon fiber added on the bottom. And both beams worked exceptionally well. There was nothing at all wrong with Alfred Yee's beam after even 50, 60 years of use. So yeah, an incredible innovation. I haven't seen many others doing the same thing with driven piles. We tend not to use driven piles so much anymore because they make a lot of noise. So putting them in is noisy. So we avoid them, but Alfred Yee knew how to use them efficiently. I think we have Kelsey on the ground in the parking garage.
Okay, Kelsey, are you there?
Yep, I'm here.
Yeah, would you mind showing? Yeah, those are the piling that Ian was talking about.
If we can show that video, yeah, just keep that video link, because now you can see essentially the pile cap becomes the capital. That capital on top of the column is now the pile cap, but it is shaped so that he can then rest the precast beams coming in both directions. He can rest those precast beams on top of that pile cap and continue with the structure, the construction up above. So yeah, the man was full of innovation.
This is great, Kelsey. Thanks for showing us around live. I feel like I'm in like a football stadium doing a live, commenting, on the sport. But this is my sport actually. So moving on to next, Ian, would you like to talk a little bit about the Ala Moana Hotel, about
Sure.
NMB Spice and
So
brand? Yeah, go ahead.
So I think I made a mistake when I told Bandit that you couldn't talk about Alfred Yee in 5 minutes, because then he gave me 3 buildings and said, well, I'll give you 15 minutes, see if you can cover it.
Yeah, so please continue. We just have to roll with it.
So what I love about this building is that it is 100%. Oh, are we hearing? No, yeah, sorry, we have to get to the.
It's the Ala Moana Hotel, not 1350. Would you mind shifting it to, go back? Yeah.
Right before that, this is it. Yeah, start there. Yeah, thank you. So this is the tallest, at the time it was built, it was the tallest precast structure in the US. And it is 100% precast. The foundations were poured in place, but everything else, all the columns, all the walls, all the slabs, everything was precast in Kapolei or Campbell Industrial Park and shipped to the site when it was needed and then lifted into place. Now, precast has a lot of advantages, as we've been talking about in the past, but one of the disadvantages is that it's individual pieces that have to be connected, have to be joined together. And at the time, there were some means of joining them together, but Al Yee didn't like any of them. And that's because he had a better idea. So if we can go to the next slide. And the next one after that. His idea was developed from this Chinese finger trap or Chinese finger trick that he obviously knew as a kid. On the top left diagram, you see woven bamboo strips, or now they make them out of plastic or paper. And they're woven in such a way that as you push your fingers in, the loop expands. And so your fingers go in quite easily. But when you try to pull your fingers out, these loops tighten in on you. And they make it difficult to, I don't know if you played with these as a kid or more recently, but it's a very effective way of keeping your fingers trapped. And so Al Yee developed what you see in the middle, which is a steel splice sleeve. It's a hollow steel tube. It's slightly tapered up on the top end. It's rough on the inside. It has deformations or bumps on the inside of that steel tube. And you put one piece of rebar in from the one side, the other piece of rebar from the other side, and then you fill the interior with grout, with a cementitious grout. And as you try to pull those bars out, they have bumps on them as well. And so the bumps on the rebar push the grout, and that grout then pushes against the bumps on the inside of the finger trick, and you cannot get those bars out. The bars will break at either end of the sleeve. So a very clever idea. And right on the right-hand side, you see how you can precast those into one element. So the top element here has them precast in. The bottom element only has rebar dowels sticking out that are just the right length. This would be almost impossible to do in the field because you wouldn't get it accurate enough for those bottom dowels to line up exactly with the precast, with the splice sleeve above. But because you're precasting all of this in a factory setting, you can get the precision you want. And so this was an ideal mechanism for tying these two members together. It is one of the best coupling sleeves available on the market, period. From a seismic perspective, particularly, it's amazingly resilient. There are other welded sleeves, there are screwed, bolted sleeves, there are all sorts of different things. None of them work as well as the NMB splice, now known as the NMB, but I call it the Al Yee splice. It's his, it was genius. So this entire building, let's go back to the image of the park, of the one slide back. This entire building is built with those sleeves. You can't actually see them in any of these images, but up on the top right-hand figure, you can see another genius idea by Al. Instead of constructing the columns as some single pieces and the beams as single pieces, and trying to splice them all where you see that black area in the middle, trying to splice them all in place. Also because, yes, thank you, Bandit. Also because that is the highest stress section of this frame. This is a moment frame resisting earthquake and wind loads. And the highest stress point is in that joint. So Al Yee said, well, let's pour the whole tree as one piece. So in fact, that joint is just, what you see here is just a recess. But behind that, the column actually goes continuous through the joint. The actual joints are in the middle of the height of the column. So if you slide your cursor down slightly to where there's timber down, there, that's the joint in the column. And it's at the point where the moment is zero under earthquake and wind load. And if you go to the beam, the end of that beam there to the right, there you go. That's the splice in the beams, which again is at the zero moment point. So the lowest forces on the beam due to earthquake is where he put the splice. And then he put the best splice in the world. So this is and then he thought, well, wait a minute, why do I make one cruciform, one column, one beam? Because these things are less than 9 feet wide, as Myles mentioned, the height of the column. I can do 2 of these in a row. I can make a double tree. And so I think there was a picture on the previous slide. If you go back one slide, not really. But in the handout, in your guide book, you will see that there's a picture, I believe, of the double tree being hoisted up and placed in place in that building. So multiple innovations in one building. Also, the tallest building in Hawaii at the time, 390 feet, which was opposed by the TV companies because their signals couldn't get around the building. And so soon afterwards, the city put a height limit of 350 feet, which lasted into this century, I believe, before the first Hawaiian building could be built downtown, which exceeds the 350. So yeah, Al Yee was way ahead of his time in many ways. So thanks, Bandit.
Thank you, Ian. This is fantastic. It's good to know about all this fact that you mentioned. And just for FYI, for everyone, they have a good restaurant up there as well that just we went up and we didn't see any spalling at all. So that's one of those things.
Well, another personal story. Let me just back up a little bit. My son got married about 4 years ago, and we brought a lot of our family from South Africa. My wife and I are both from South Africa, and we brought a lot of our family, and they lived on the 32nd floor of this building in one of the basically penthouse suite at the end of the building. It's just tremendous. I mean, there is no better view from the Ilikai and from the Ala Moana Hotel, except maybe 1330 Ala Moana, which you'll get to shortly. But yeah, a beautiful building. Very, very good design.
This is great, Kelsey. Yeah, you can show what it looks like now live from the Ala Moana Hotel. So, and the parking garage right there. There you go. Yep, this is good. Yeah.
Something else I didn't realize about this building until I was reading up on it for this presentation was that it was partly developed by American Airlines because they needed a place for their staff to live. And why not invest in a hotel? And so the wing at the back, actually, if you hold that video shot, hold that shot, the 13-story wing at the back, I had never realized is intended for airline workers and is still used by them. So yeah, fascinating the partnership that happened to construct this building.
Thank you so much, Ian and Kelsey, for sharing your time with us. Should we move on to the next building, which is the Equus? So yes, yeah, this is the Equus Hotel, known as the Driftwood Hotel, not too far along that walking route that we share with you in the map, for the walking tour. So, so what I'd like to let you guys know a little bit about the next speaker. His name is Roy Noda. Unfortunately, he's not able to make it with the walking tour today. But one thing about Roy that I found we met up and talked a couple of times. What he's known for is what I like to do another walking tour or the floating tour next is he's the specialist in floating structure barges. That's something that I see could be a great potential on our island, given the fact that the water is rising, the price of real estate is rising up, and a lot of people are trying to capitalize on it. But with Roy's knowledge, he talks about barges. Whenever you talk about barges with him, he has that sparkle in his eyes, and that I found it very rewarding to see in a person, an engineer that worked with Al. And just to be honest, when I interview Roy and even Al's family, barges is one of the projects that he always wanted to do a little bit more. And here is Roy Noda. We had a talk with him yesterday that he shared a little bit about the building. Thank you.
Okay, so I'll be talking about Equus. Basically, it was constructed in 1960, 2 years before the Ilikai Hotel. And around that time, I guess prestressed, precast concrete was kind of, well, I would say in its infancy. So the Equus utilized precast spandrels with hexagon to simulate the tropical atmosphere or theme. And the architect was Wimberley and Cook for the Equus. Before that, the hotel was named Driftwood Hotel. And I guess they wanted to keep that Hawaiian theme or heritage. So they had driftwood and coral at their lobby. But back in 1990, the son of the founder, Mike Daly, he took it over and renamed the hotel Equus. But prior to that, the hotel was owned and operated by Mr. Daly. I forgot his first name. Anyway, so and the contractor, I believe, was Pacific Construction, and I think it was Henry Freitas. Yeah, George Freitas. Yeah. So he was a licensed civil engineer, educated in Hawaii, and so that was the beginnings of Al's, I guess, precast, pre-stressed kind of structure. If you look underneath the parking structure, you'll see that they incorporated the or it looks like ashto type beams, the I-beam, and those are pre-stressed, connected to precast concrete or cast in place concrete columns, and probably most likely cast in place slab that connects the ashto or I-beams. The hotel's on a very narrow site, so what's unique about this hotel is it has a great view of the ocean and the mountain, and it was oriented such a way that it was the narrow side facing the ocean versus the wide side facing the ocean, which is typical of a lot of the structures now that you see throughout Waikiki and through Kaka'ako, to take advantage of the view that they have. So at that time, Equus was probably one of the tallest at 10 stories. And it's also a first co-op structure. So that's pretty much it.
All right. Yeah, it's a little bit light in terms of sound. We kind of apologize for that. We try our best to really bump up the sound, but it didn't work as we intended. So
I guess one thing though I wanted to add to Roy's explanation, Fred Daly, who was one of the owners of the building originally, he owned the Waikiki Inn that used to sit next to the Ala Wai, or the Ilikai, I'm sorry. And he was actually also a very good poloist and very influential in reviving the sport of polo in Hawaii. Another thing I also want to point out is, I guess if we can see Kelsey's camera in real time, you can see the use of decorative trapezoids in the precast panels. This is something quite unique among the buildings we are seeing today. Rather than just kind of like a flat, plain panel, they incorporated this trapezoidal-like relief in the panels, which kind of provides some identity, as well as some nice shadows along the building's exterior throughout the day. So if we can see more of Kelsey's camera.
Kelsey, are you down on the street?
It's Keith. Look for Keith's camera.
Okay, Keith.
Yep, I'm here.
Okay, there you go.
So yes, if you can zoom in a little bit, we can kind of see those trapezoidal shapes on those balconies. Those are all precast panels, and just adds just a little bit of decoration, especially against some of the neighboring buildings that it sits between.
Yeah, and this is the early building by Wimberley and Cook of WATG this day, but this is the early work. Quite interesting the way it's laid out as well. All right, let's move on to the next one. Thank you, Keith, for being on the ground. Yeah,
No worries.
awesome.
All good.
Okay, the next building is the Sunset Tower. This is the early work as well from Alfred Yee office. The project engineer that worked on this is Chang Nai Kim, his close associate with LE. I had a chance to sit down with him 2 weeks ago at the plaza, one of the building for elderly housing. And it's just a joy to be around him. You know, we share with him old drawing, the set that he stamped and signed, and he remember, you know, in details about what it is at every corner that he put his hands on. So without further ado, I like to be able to share the video that I recorded at the parking garage at the plaza with Chang Nai Kim. Yeah. So please go ahead, Graham. Thank you.
I was an associate of Alfred Yee since about 1965. And during that time, we did many projects, of course. One of the early ones is called Sunset Towers, located on Atkinson Boulevard, across the street from the Ala Moana Hotel. This was a building that was condominium apartments, and at that time they had a design called a wedding cake type design, in which we were controlled by the allowable frontage to the front property line, so that the building had to be stepped back after a certain height. And it was named the wedding cake design. So this Sunset Towers was an example of that period. The structure was a combination of cast in place concrete, generally the walls and columns, and a precast joist system combined with the cast in place slab. The minimum thickness for the slab, according to the building code, for 2-hour fire protection is 4.5 inches. So we spaced the precast joists so that we can have a 4.5 inch slab. Starting from the foundation, going over the precast elements that were introduced. First was the precast concrete piles, which were developed by Alfred Yee. At that time, the industry was using steel piles, but as soon as the precast piles were introduced, because of the effective cost and structure, it became the item that was used pretty much in Waikiki for high-rise buildings. The members were frequently 12-inch square, which was used in this project, Sunset Towers, but in other projects for much taller buildings, we went to a 16.5-inch octagonal pile. The typical floor system was precast concrete joists that spanned across the whole building, spaced at approximately 8-foot centers, and then it was able to support a 4.5-inch concrete slab cast in place. That is the typical floor that was used. There was variations in that building to accommodate the wedding cake design. At the upper floors, the bearing walls were wider, maybe up to 10 foot wide. But when it came down to the lower levels, the size was reduced to maybe 2 feet to accommodate the requirements of the lower parking and the lower levels. But this, but when you go from 10 feet to 2 feet, there's an unbalanced moment. So this is backed up by the same kind of structure opposite to us, so that we have opposing, equal and opposite opposing forces. This structural system was also adopted for the Kahala Hilton Hotel. Let's see. So pretty much this idea was used throughout. I think that's a basic concept of what we tried to do.
Okay, thank you, Kelsey. Kelsey is on the ground now showing the Sunset Tower. This is the wedding cake design. And the architect is the Donald Haynes, local boy that moved to San Francisco, but come back and do this building for us. My impression about this building is the slab is so thin that I kind of like it very much. And yeah, Kelsey is pointing at it now. And the way that the stone is used and the perforated metal aluminum panels is used, I think it's very appropriate for what it is. It high order parking garage, yet set the scale for the tropical modernism way of looking at things.
And I guess to add to that, in the gold color metal panel screen at the front is probably more the thing that is probably it's most recognizable for. I'm sure a lot of you probably have noticed it. It adds a bit of decoration, as well as kind of screens that parking the first three floors of the parking garage. Some other fun facts about this building is that the building was noted in newspapers and advertisements to include one of the first buildings to include floor to ceiling windows, with the addition of gold colored glare proof tint on the Mackay side windows, kind of a new technology of that time. Ceramic tile on the living room floors was also something very new. I saw an advertisement that it indicated that the tile would be easy to clean and provides a surface with minimal wear, and suggests that, you know, maybe an addition of a large floor rug would dress up the living room floor. So, you know, it's kind of fun facts, and a way to incorporate some of these new things at the time, but stuff that we still see today.
All right, thank you, Alyssa. Should we move on to the next one? So the next one, our next speaker, his name is Jimmy Lam. Jimmy Lam is a principal at Akamai Structural Engineering firm. I work with Jimmy quite a bit on various projects. He's another young and upcoming, very good structural engineer that I like to introduce him. Jimmy, why don't you take it away? Are you there?
Hey, Bandit, thank you. Can you hear me? Okay, good afternoon, everyone. Before I begin, I just want to take a moment and thank Docomomo, Hawaii, and the awesome team of Bandit, Alyssa, and Kelsey, who's worked tirelessly to put this event together, allowing the speakers the opportunity to share with you today. So yeah, thank you so much. As Bandit mentioned, I'm a local structural engineer. I've been in the profession for about 20 years. So Dr. Yee was a bit before my time. That said, I do recall learning about Dr. Yee in college when I took a graduate level precast concrete design course from Dr. Ian Robertson, who was also my college professor at the time. So yes, Hawaii is very small indeed. Also at that time, I learned that Dr. Yee was one of only 2 engineers from Hawaii that was inducted into the National Academy of Engineering. The organization pretty much highlights the who's who in engineering, and it was and still is a very big deal. And then after college, and then throughout my career, I've had many opportunities to work with Dr. Yee's former employees, and I've toured a few of his completed projects across the Pacific. But today we'll focus on building 1350 Ala Moana. So 1350 Ala Moana was designed by architect Minoru Yamasaki and structural engineer Dr. Alfred Yee. Both were already internationally known designers. And Dr. Yee was also recognized as a world leader in and manufacturer of the use of pre-stressed concrete. The duo also designed the Queen Emma Gardens on Nuanu Avenue on Oahu prior to this building. Many design features from Queen Emma Gardens are reflected in the design of this building, and we'll try to point them out as we do this walkthrough. The project site is built over the previous Billingham Corporation's main headquarters. The location was known to be the hub of Honolulu, all in easy access to shopping, recreation, and business, and is accessible by car, bus, and within walking distance. The rectangular shaped building sits perpendicular along Ala Moana Boulevard with the design intent to provide an unobstructed panoramic view of either Diamond Head to the sea or Honolulu Harbor to the Waianae Mountains. So this is before all the buildup in Kaka'ako occurred. And of course, back then when you had that longitudinal towards direction of the building facing Diamond Head and the west side, you had unobstructed views. The building itself is 34-story, and it was a luxury residential condominium. It stood at about 309 feet high and boasts a whopping 353 units. Construction of the building was completed in 1968 by Hawaiian Dredging Construction Company for $10 million. Also at the time, it was the tallest building along Hawaii skyline, exceeding the height of the Ilikai Hotel. And as you can see, in 68, that was the tallest building at that time. In 70, it was beat by the Ala Moana Hotel that Dr. Robertson went over just a few minutes ago. Also, it's advertised that the seventh penthouses at the top of the building can look down at all of the other concrete giants in Honolulu. This brought sort of a concern from local television stations, blaming all tall buildings for interfering with TV signals to other parts of the island. Also a sign of the times that you'll notice is that each unit came only with one parking space, while units typically have 2 bedrooms in them. From a structural standpoint, the building's floor system consisted of pre-stressed concrete planks with concrete topping that required a comprehensive load testing program performed in accordance to the American Concrete Institute guidelines. Using this design method, it allowed for floor-to-ceiling windows and large balconies, which was reinvented from the precast concrete sunshade shapes used at the Queen Emma Gardens. The lateral force resisting system for this building seems to be reinforced concrete stair and elevator cores with precast concrete panel shear walls sandwiched in between those full height slender windows, which is also a system used at Queen Emma Gardens. And finally, the amenities included a large landscape garden setting with a large oval swimming pool and waiting pools for the kids, 4 high speed, whatever that means at that time, elevators and 24-hour security with a restaurant on the 3rd floor. AC at the time was optional, and if desired, wiring was pre-installed for each installation. So, yep, that's what I have to share about 1350 Ala Moana. Thank you again for the opportunity. Bandit, back over to you.
All right, Bandit just stepped out, but we'll just show Key. Thank you for showing the 1350. They just recently painted this yellow, and you can see the knives, and then you can kind of see how the main level is raised, and with the parking at the base.
Alyssa, Keith, are we able to zoom in to perhaps the underside of a lanai to show that it's, you know, the design is not your typical rectangular lanai, but it has that edge,
it's got a curve
on
it,
it, which makes it, using a precast method,
I mean, I'm across the street right now, so I can't zoom too close.
More effective, I guess.
But
Hard to see, yeah.
A little bit hard to see.
Yeah,
Thank
that's
you.
like all across the road. I can't get to it that much closer.
Okay. Oh, here's Bundin. Bundin's here. I'll let him introduce our next speaker, Richard Lowe. Just a moment.
Okay, thank you, Kelsey. This is great. So the next speaker, whenever we do a show or any exhibition, my intention is not just to show it just for the architect or the structural engineer. My goal is just to bridge all other professions as well. And Richard has always been a part of our gallery, and he's trained as a city planner. He's gonna turn 93 this year, and he came here when, what year did you come here, Richard?
1964.
Yeah, I want to keep the last speaker as a way to express his vision of Honolulu from the urban planner point of view. So just to wrap it up, and so here's Richard Lowe.
Thank you very much. I came here in 1964, brought here by the architecture firm that designed the state capitol and that obtained a couple of important planning jobs as well, so that I worked for both of those. One was a master plan for the civic center surrounding the state capitol. And the other one was a master plan for one of the land companies that owned a large piece of acreage just across the street from the ocean. And that's called Ward Village right now. It's gone through different ownerships. But because of all of those buildings, and because of, when I arrived, I came up by car from the airport, and I was with someone else, and we saw the edge of Queen Emma Gardens, which has been spoken of already. And Queen Emma Gardens is, in my view, one of the very best buildings, and it's the result of a wonderful corroboration between Al Yee and the architect, Minoru Yamasaki.
So, Richard has first glance, when he arrived in Honolulu with the Queen Emma, which is one of the best building design this day. Used to be a low-income housing, but that's one of the very fine example that what we like to do next is to do a Docomomo walking tour, maybe somewhere in that area. So that's something that I like to share with you guys, just a part of our events for the next one. Without further ado, I'd like to pass it on to Alisa to wrap up our tour for today. And here's Alisa. Yeah. And the restaurant start, to serve things, so which is very nice. I feel like this is my weekend that I can share knowledge, on top of Ilikai Hotel designed by Alfred Yee.
Well, thank you all for joining us. We have a few minutes, so I just want to answer the kind of two questions that came in. One was in regards to the Waipuna pond. I believe it's still there. I think we can kind of see a portion of it from where we're sitting. And then the second one was in regards to the other gentleman that was inducted as a structural engineer. We will have to get back to you on that one. But thank you for your questions. So without, I guess to wrap this up, thank you again for taking the time out of your afternoons to be with us today. This was very special and quite the honor for us. I just want to again send a shout out to our sponsors, guest speakers, Pesco, Waikiki Beach for hosting us here at the top of Ilikai, and everyone else who made this event possible. And most of all, a huge mahalo for all of you for attending today. I really hope you enjoyed this event. Again, so feel free to email us any questions, comments, and if you want to purchase a book, again, please purchase them on our Eventbrite page. We'll post it again on our chat. And we hope to see you again at another Docomomo Hawaii event. Until then, please continue to stay safe, healthy, and enjoy the rest of your weekend. Bye.
Bye-bye. Thank you. Wow. All right.
Thank you. Bye-bye.